Last week, we touched a bit on SQL and MySQL and its relation with Java database connectivity. Over this week and next week, we'll focus a little more on the MySQL concepts related to potential web development. As always, prior homeworks and projects are available for review online. So what does SQL stand for? More commonly spoken as SQL, Structured Query Language. MySQL is a relational database management system. You may see that abbreviated as DBMS. /H is how you ask for help in MySQL. /Q is how you exit in MySQL. The Q represents quit. /C is how you cancel a command in MySQL. Often when trying to execute a command in MySQL, you will use the command commit in order to execute what you're trying to do. SQL is a standard spaced query type. As previously mentioned, MySQL is a relational database management system. There are some advantages associated with SQL. You can use large amounts of data within them. They're flexible, secure, and reliable. There's also third-party support available online. And unlike other database programs such as Access, you can optimize performance once you have a basic understanding of these concepts. SQL was developed by IBM. These other pieces of information are summaries of what I have already stated regarding what SQL stands for and what MySQL is. So why do people prefer to use SQL over Access? Access is client-side. You do all the work. SQL is server-side. Also, SQL can be used with all the other aspects we focused on in this course. HTML, PHP. Access is more prone to freeze, as well as Access requires you to purchase Microsoft Office, and in some instances may not work on a Mac. SQL offers free options, however. So what can SQL do? Well, you can create queries. You can utilize multiple statements at the same time with your commands. You simply separate them by a comma, and like a lot of programming languages, a semicolon at the end to indicate your command or statement is complete. You could create a database. You could create a table. You can show tables, describe tables, and delete tables. You can load data. You can select data, which we will see later specifics on how to select from and where. And you can also sort data. So DBMS, Database Management System, is bottom tier database server. That means it's basic. PHP is a middle tier web server, and HTML is a client tier. As you've seen with some of your assignments, you do not even see or need to have specific web server access for some HTML code to run. So here's SQL with PHP. Notice, just like with our forms, we have our PHP code and our end PHP. So what is this doing? Well, we're creating a form, similar to what we did in week 11. So how does SQL work? Well, you create a schema. You identify the schema name, and you may include authorizations. Schemas often include tables, types of constraints, views, domains, and other specific constructs. As you previously saw, all SQL statements need a semicolon at the end to run properly. So here's a visual. A create schema statement. Create schema, company. That is the name of our schema, company. Authorization, J. Smith. That means whoever J. Smith is the only person who has the authority to utilize the schema company. You may have a catalog, which is a named collection of schemas within a specific SQL environment. This is quite common if you have a database course and an instructor has specifically set up a catalog of multiple schemas for you to use. SQL also has the possibility for you to have a cluster of catalogs. That means multiple catalogs. So, what are the basic data types? You may have numeric data types, such as integer, int, small int. You may have floating point numbers, float, real, double precision, similar to programming languages. You may also have character string data types, as you saw with the assumptions. They can be fixed length, such as char or character, or varying length, such as varchar, which you saw in the assumptions previously. You might also have bit string data types, and Boolean, which is a true or false, or null, which is a missing value. There are also date data types. You may have year, month, day in various forms as you need. You can also have timestamps. There's even an option for you to have a time zone qualifier. There are a number of integrity constraints within SQL that you have to have. In Access, there's no need for these. Access just lets you do as you need. A key constraint requires that you have a primary key value that cannot be duplicated. You must also have an entity integrity constraint where the primary key value cannot be null. So if you have a primary key, for example, of a student ID, there can't be two student IDs for one student. That's our key constraint. And the student ID can't be empty. That's our entity integrity constraint. There are also referential integrity constraints, where the foreign key must have a value that is already present as a primary key or may be null. That means if you're taking information from one table that has a primary key and associates with a second table, the first table must have information within that field to meet the referential or reference integrity constraint. Here's some example SQL code. Here, we're creating the table employee. We are creating a department number int that is not null and default as 1. That means information must be inside of it because it is not null. We have our primary key set up as social security number, our foreign key set up as super social security number. Here we have another example. Create table department. The manager's social security number is set as 9 characters. Again, a primary key set up, a foreign key set up, etc. Here, we're only creating a department locations table with our primary and foreign key. We're only referencing other variables that have been created. So how do you do assignment 14? Well, you're considering all the banking information you may have. You may have a branch, a customer, an account, a loan, a depositor, a borrower, and an employee. But you may have information associated with them, so they go inside the brackets next to them. So a branch name, a branch city, assets within that branch. For customer, it would be customer name, customer street, customer city. Feel free to bring it out even farther. Customer state, customer country. For account, you may have an account number, branch name, balance. You may have credits, debits. For loan, you have loan number, branch name, amount. You may also have interest, number of years. For depositor, you may have customer name and account number. For borrower, you may have customer name and loan number. For employee, you may have employee name, branch name, salary. You may have years of service, other information associated with that. You'll notice the underline are important. They are usually set as the primary key, or in some cases, you may have multiple keys. So SQL notation, you have your table name with the fields inside the brackets. As mentioned, the underline is a key attribute. It may specifically have been set as your primary key. These attributes, or fields if you've used Access, can be written as name underscore name, name dash name, or name name. It depends on which name you have to specifically set up for the SQL notation. And that is the end of our introduction to SQL. Next week, we will touch on much more within SQL and help you build your final project.